Good day, students. Now consider the next characteristics of the continuous random variable, named the median. Right? The median, the median, the median, the median, the median of the continuous random variable, continuous random variable. Continuous random variable. The median is such a value denoted as ME, for which integral from minus infinity to ME f of x dx equals integral from ME to plus infinity f of x dx is 1 second. It means the probability that the continuous random variable will belong to the interval minus infinity ME and interval ME plus infinity is equal to 1 second. Really, remember the main probability equality. According this equality, integral from minus infinity to plus infinity f of x dx is unit. Then it is the main probability equality. We can separate this integral into two following integrals. Integral from minus infinity to ME f of x dx and plus integral from ME to plus infinity f of x dx, and it is equal to unit. If this integral is 1 second, then another integral is also 1 second, because the integral from minus infinity to ME f of x dx equals 1 minus integral from median to plus infinity of x dx equals 1 minus 1 second, and it is 1 second. Then let's prove this fact, that if the distributive density is a symmetric function with respect to some value a, then median of the continuous random variable is equal to the symmetry center. That is, if f of a minus x is equal to a f of a plus x, that is, if function f of x is a symmetric function with respect to a, here a is symmetric point, then the median is equal to symmetry point. it is symmetry point. Symmetry point. Symmetry point. Proof. Proof. First, consider the integral from minus infinity to a, f of x dx. F of x dx. Here, please make the first change. First change. Let x is x is a minus t. A minus t. That is t is a minus x. A minus x. Then dx, find dx is d of a minus t equals dA minus dt, because for differential, the differential of or the difference is the difference of corresponding differentials. A is constant value and differential of the constant value is 0, therefore it is minus dt. Dx is minus dt. Then also change the integral limits. If x is minus infinity, because this integral is taken with respect to x. X is minus infinity, then find tangential for t. If substitute minus infinity instead of x, we will obtain t tends to plus infinity. Plus infinity. A minus infinity is a plus infinity, and a here constant value. And if add constant value to infinity, then we will obtain infinity, plus infinity. Here t tends to plus infinity. Then if x is a, then t is 0. T is 0 because if substitute a instead of x, we will obtain a minus a is 0. It is first change, then continue. Integral from plus infinity to 0 of f of a minus t multiplied by minus dt. Then we can take a negative sign out of the integral symbol. Minus integral from plus infinity to 0 f of a minus t dt. Then change the places of in integral limits, and you know that if change the places of the integral limit, then the sign of the integral itself will be changed. Therefore, we will, but already we have minus will be plus integral from 0 to plus infinity of f a minus t dt. Then continue. We have integral from 0 to plus infinity f of a minus t dt. Then make the second change, right, second change, second change. Let here z is let here a minus t, and here remember that the function f of x is a symmetric function, and therefore according to this this equality we can rewrite f of a minus t as a f of a plus t. Substitute change f of a minus t by f of a plus t according to the condition of symmetricity of the function f of x. And here we'll have integral from 0 to plus infinity of a plus t dt. Then make the second change. Here we must change a plus t by z. For example, let it is z. A plus t is z. Then t is z minus a, and dt is d of z minus a, dz minus dA. dA is 0 because a is constant, and therefore we have dz. Then if if the t is 0 because here integral limits are taken with respect to variable t, and therefore we must obtain the integral limits with respect to z, new variable z. If t is 0, then substitute 0 instead of t, then z is a. And if t is plus infinity, then if t is infinity, a plus infinity is infinity, z is plus infinity. Then continue. Then continue our proof. Already we obtained that now applies the second change equals integral here 0 is transformed to a, and plus infinity is transformed also to plus infinity into plus infinity. F of z and dt is transformed to dz because dt equals dz. And also you know that the numeric value of the definite integral doesn't depend on the integral variable. If change the variable of integral, then the value of integral will be kept. Therefore, we can change z by new variable x. Integral from a to plus infinity f of x dx. That is already we obtained that integral from minus infinity to a f of dx. F of x dx equals integral from a to plus infinity, infinity, f of x dx. Then continue. Then continue. Then we have the main probability equality, integral from minus infinity to plus infinity, f of x dx is unit. Then separate the integral into two integrals. One of them is taken from minus infinity to a, and second is taken from a to plus infinity. Minus infinity to a, f of x dx, plus integral from a to plus infinity, infinity, f of x dx is a unit. Then continue. 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 But we have the following result, this result, and therefore we can change the first integral by the second integral. Integral from a to plus infinity, f of x dx, plus integral from a to plus infinity, f of x dx is 1. Then twice integral from a to plus infinity, f of x dx is unit. Then this integral itself is equal to 1 second. Integral from a to plus infinity, f of x dx is 1 second. 1 second, and also the left integral is also equal to 1 second. Integral from minus infinity to a, f of x dx is also 1 second. 1 second. That is, we proved that for symmetric function, the median of the continuous random variable is equal to the symmetry point, symmetry center. In general, if the distributed density is a symmetric function, then the mode, the median, and the mathematical expectation of the continuous random variable is equal to the symmetry point. Then draw to the graph of the symmetric function. Symmetric distributed density. You know that the f little of x is named distributive density. Y x, let it is point A, minus infinity to plus infinity, and construct the graph of the symmetric function. It means the both branches of this graph is symmetric with respect to the symmetry line, symmetry axis. Symmetry axis x is equal to a, and it is distributive density is the symmetry function. Here a is named. I'm sorry. Here a is first symmetry center symmetry center. Symmetry center or symmetry point. Center. Second, it is mode because at this point our function has a maximal value. Maximal value. It is maximal value. Maximum of y. Maximum value. It is also mode. It is also the mathematical expectation. Mathematical expectation. 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 And finally, it is also the median. 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 Now let's solve the example on the median of the continuous random variable. Write example. Find the median. Find the median. Find the median of the continuous random variable, of the continuous random variable given by the distributed density f of x is x minus 1 second for x between 1 and 2, for x between 1 and 2 and 0 for outside solution. Here we have three intervals from minus infinity to 1, from 1 to 2, and from 2 to plus infinity. Therefore, draw these intervals. Minus infinity, plus infinity, 1, 2, and three intervals. In this interval, f of x is 0. In the middle interval, it is x minus 1 second. And in the right interval, it is 0. F of x is 0. First, check that for f of x, the main probability equality is satisfied. Consider the integral minus infinity to plus infinity f of x dx. Separate this integral into three integrals. integral from minus infinity to 1 f of x dx, plus integral from 1 to 2 of f of x dx, and plus integral from 2 to plus infinity f of x dx equals in the first and third intervals f of x is 0, and the definite integrals of 0 are 0, and in the middle interval f of x is x minus 1 second. Substitute x minus 1 second instead of f of x in the middle interval. 0 plus integral from 1 to 2 of x minus 1 second dx plus 0. Then open this integral, calculate this integral. The integrand is x minus 1 second, and the antiderivative of this integrand is 1 second x squared minus 1 second x. X squared in a half minus x in half from 1 to 2 equals first substitute 2 instead of x minus then substitute 1 instead of x in this expression. 2 squared in half minus 2 in half minus 1 squared in half minus 1 squared 1 second, I'm sorry, 1 second equals, it is 2 minus 1 minus 1 second minus 1 second is 0, and we obtain unit. And here the main probability equality is verified. That is, integral from minus infinity to plus infinity f of x dx is unit. It is the main probability equality for the continuous random variable. Then find the median itself. Then find the median itself, and for this we must write the following equation. Integral from a to plus infinity is equal to f of x dx is 1 second. 1 second. And you must know that the median belongs to the non-zero interval. Here we have the interval, non-zero interval is 1, 2, in which the given function is not equal to 0, and a belongs to this interval. Therefore, we can separate this integral to two integrals. First, draw the intervals from minus infinity to plus infinity. 1, a, 2. Here in the left and in the right intervals, f of x is 0 according to condition, to the given condition, and in the middle interval f of x is x minus 1 second. Minus 1 second. Here then mark the integration intervals from a to plus infinity. And therefore we can separate the in two integrals from a to 2 and from 2 to plus infinity. Integral from a to 2 f of x dx plus integral from 2 to plus infinity f of x dx is 1 second. In this interval from 2 to plus infinity, f of x is 0, and therefore the second interval is 0, and in the first integral we must change f of x by x minus 1 second. 1 second. 1 second. Integral from a to 2 of x minus 1 second dx is 1 second. Here integrand is x minus 1 second. Its antiderivative is x squared in half minus x in half with double substitution from a to 2 is equal 1 second. 1 second. Here we can multiply the both sides by 2. Then we will obtain x squared minus x with double substitution from a to 2 equals unit. First substitute 2 instead of x, then substitute a instead of x, and finally we must find the value for a. 2 squared minus 2 minus a squared minus a is unit. Continue. 4 minus 2 is 2. 2 minus a squared plus a equals 1. They transfer all terms to the right part. A squared minus a minus 1 is 0. And we obtain the quadratic equation with respect to the unknown a, and solve this quadratic equation. First find discriminant. Discriminant is 1 plus 4 is 5. Then a 1 second is equal to 1 plus minus square root of 5 over 2. And you know that the square root of 5 is equal to approximately is equal to 2.2. 2.2 square root of 5 approximately equals 2.2, and therefore a 1 approximately is equal to 1 plus or plus only plus 2.2 over 2. It is 3.2 over 2, and it is 1.6. 1.6 belongs to the interval a2, 1 2, I'm sorry, and the way it is our answer. Second a is approximately is equal to 1 minus 2.2 over 2 equals minus 1.2 over 2 is minus 0.6. Doesn't belong to the interval 1 2. Here our answer is 1.6, approximately 1.6. Then we can find the median also by another method. Then use another method for the finding the median of the continuous random variable. Here use the following integral from minus infinity to a f of x dx is 1 second. And here a must be belong to the interval 1 2. then again draw the intervals. Draw intervals. Here 1 A, because A is situated between 1 and 2, and we have three given intervals according to the definition of the distributive density f little of x. Here f of x is 0. Here f of x is x minus 1 second, and here f of x is 0. Here we integrate from minus infinity to a, and therefore we obtain two interval for integration. And therefore we can separate this integral into two integrals. Integral from minus infinity to 1 f of x dx, f of x dx, plus integral from 1 to a, f of x dx is 1 second. 1 second. But in the left integral, distributive density is 0, and definite integral of 0 is also 0, and here we must substitute x minus 1 second instead of f of x. We have integral from 1 to a of x minus 1 second dx is 1 second. The antiderivative of x minus 1 second is x squared in half minus x in half. X in half with double substitution from 1 to a is equal to 1 second. Then multiplied the both parts of the last equation by 2. Continue. Then we have x squared minus x from 1 to a is unit. First substitution a, and then substitute 1 instead of x. A squared minus a minus 1 squared minus 1 is unit. This expression in the second parenthesis is 0, and then we obtain the equation a squared minus a minus 1 is 0, and already we add this equation, and here we have two solutions. At first calculate the discriminant. 1 to 4 plus 4 is 5. Then a first second equals 1 plus or minus square root of 5 in half. First calculate the a1, and remember that square root of 5 approximately equals to 2.2. Then substitute 2.2 instead of square root of 5. A plus 2.2 over 2 is 1.6. 1.6 belongs to the interval 1, 2. And second A is 1 minus 2.2 over 2 is minus 0.6, which doesn't belong to the interval 1, 2. Therefore, our median is 1.6, and this median is verified. And finally, please write your homework homework, 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 homework. Homework. The distributive density f of x is equal to x plus 1 second in the interval 0 1 and 0 outside this interval, outside. Find the median for the continuous random variable with the given distributive density. Find the median. Thank you very much for your attention. Good luck. Goodbye, students. Please rewrite the homework.